Here we have these polar equations, and if we graph these equations of this type, and then they will either be a parabola, an ellipse, or a hyperbola. And uh, if the E right here, we call that the eccentricity, if it's equal to 1, then we're getting a parabola. But if the E is less than 1, then we're getting an ellipse. And if E is greater than 1, then we get a hyperbola. And so now let's look at some graphs, so we can see that these type of polar equations, they do generate parabola, ellipse, and hyperbola. And so here I have a parabola that opens to the right, and this is called the directrix, and this is the focus, which is at the pole. And so for this type of equations, polar equations, the focus will be the pole, be at the pole. And so to generate the points on the parabola, then we have to have the distance from the point to the directrix is the same as the distance to the focus. And so we pick this point right here, then the distance from point to focus must be the same as distance from point to directrix. And same thing here, the distance from point to focus must be the same as point to directrix. And for parabola, the eccentricity is defined as the distance from point to focus dividing by distance from point to directrix. And since these two distances are the same, then that's why the eccentricity be 1. And once again, the focus be at the pole, which is 0, 0. And the eccentricity is defined as distance of a point on the parabola to the focus dividing by the distance from the point to the directrix. And since when in the parabola we require that this distance and this distance be the same, so that's why eccentricity is 1. And then d is the distance from the focus to the directrix. And so for this particular example, the distance from focus to the directrix is 8, and therefore d will be 8, and d is always going to be a positive number. And now we will look at what happened when we changed the directrix, then what happened to the shape of the parabola. And so here we have 10. So if the directrix is 10, then we get this parabola. Here's directrix for 9. And notice again the focus has to be at the pole. And here's 8. And here's directrix of -6. Directrix of -5. Directrix of -4. Directrix of -3. Directrix of -2, and directrix of -1. And so the eccentricity number is going to be 1 here and then 1 here. Eccentricity is 1 and 1. And then this number is always going to be the absolute value of whatever the directrix is. So in this case it's -10. Then take the absolute value of that and we get 10. And so if we have parabola that opens to the right, then we're going to get 1 minus eccentricity times cosine of theta. And now let's do parabolas that open to the left. And so for parabola that opens to the right, again the focus has to be at the pole. And here we have the directrix of x equal to 10, and so that's what that 10 is in the equation. So the equation for this parabola be r equal to 1 times 10, because eccentricity is 1, and then 1 dividing by 1 plus 1 times cosine of theta. And if we have a directrix of x equal to 9, then the equation will be 1 times 9 dividing by 1 plus 1 times cosine of theta. And then here we have eccentricity of, not eccentricity, but directrix of x equal to 8. And then the equation for the parabola, for this parabola, be 1 times 8 dividing by 1 plus 1 times cosine of theta. And then this is for 7 x directrix x equal to 7. Then the equation will be 1 for the eccentricity, and then the 7, that's the directrix, divided by 1 plus 1 times cosine of theta. And this is eccentricity 6, and so we get 6 here. And this is not eccentricity, but directrix, 6, x equal to 6. And then this is directrix, x equal to 5, so we get a 5 here. And then directrix, x equal to 4, then we have a 4 here. And then 1 plus cosine. And the difference is when the parabola opens to the right, it'd be 1 minus cosine of theta. But if it opens to the left, it'd be 1 plus cosine of theta. And here's directrix x equal to 3, so we get 3. And then directrix x equal to 2, and then directrix x equal to 1. And now let's look at the types that open up. And here we have the directrix is the horizontal line y equal to negative 10. And so right here we have 10, the absolute value of this negative 10. But the bottom is what's different. It'd be 1 minus 1 sine of theta. And here we have directrix negative 9. And so we get 9 here. And here we have directrix negative 8. So absolute value of negative 8 is 8. And then here we have directrix negative y equal to negative 7. We get a 7 here. And then directrix of y equal to negative 6. And then directrix of y equal to negative 5. Negative 4, negative 3, negative 2, and negative 1. And here we have a parabola that opens down. Again, the focus has to be at the pole. And here we have the directrix is y equal to 10. So the equation will be 1 times 10, 1 for the eccentricity, 10 for the directrix, and then if it opens down, it'd be 1 plus eccentricity times sine. If it opens up, it'd be 1 minus eccentricity times the sine. And then here's 9, eccentricity, y equal to 9, so we get 9. And then eccentricity equal to 8. And then there's eccentricity y equal to 7. Not eccentricity, but directrix. So directrix y equal to 6. Then we get a 6 here. And then directrix y equal to 5. So we get a 5 here. And then directrix y equal to 4. And so we get 4 there. And then directrix y equal to 3, so we get a 3. And then 2 and 1. And here's the summary of what we just did. If we have 1 minus sine of theta, then the parabola opens up. If we have the type that is 1 plus, because the eccentricity is 1 for parabola, 1 plus sine of theta, and then the parabola opens down. If we have 1 minus cosine of theta, parabola opens to the right. And if we have 1 plus cosine of theta, parabola opens to the left.